Hello, and welcome to the course Natural Language Processing. Natural Language Processing or NLP is an important area of data science and artificial intelligence. A number of data-centric applications that we use today on internet makes use of natural language processing to improve user experience. Some examples of those applications are search engines, in which users can write any text query to search the information available on the internet. Machine translation systems, in which one language is translated into any other language, say English to French or Russian, etc. Categorization of news into defined categories, in which any given news is classified into a defined class such as sports, entertainment, politics, etc. Other examples are conversation systems such as chatbots or voice agents, which interacts with the humans and responds to their questions or queries, or spelling correction or suggestion softwares that are included in popular document editors softwares as such. In this course, I will explain the fundamentals behind the concepts of natural language processing and also implement them using Python. Let me walk you through the contents of the entire course. First, we will understand what is text data and the concepts of natural language processing. Then, we will discuss different techniques and approaches related to natural language processing and how these techniques are implemented on real datasets. We will cover two types of datasets, structured and unstructured. Then we will discuss a specific type of unstructured dataset, text data. After that, we will develop understanding about what is natural language processing. And finally, we will see some business use cases of NLP. The first topic is types of datasets. Any form of a dataset can be classified into two categories. The first type is structured dataset and the other type is unstructured dataset. Let's discuss the properties and examples of these datasets in detail. A dataset having fixed number of dimensions, that is fixed number of keys and values, or fixed number of rows and columns is called a structured dataset. This form of a dataset contains information in a well-organized form. Generally, a structured dataset is present in a tabular format, relational databases such as SQL, or key-value pairs. For example, consider a dataset containing details about employees such as employee name, employee department, their hiring date, etc. This dataset has defined number of columns and rows, that is, the dimensions of this dataset are fixed, and thus is an example of a structured dataset. Some other examples are a table containing recordings of annual temperatures for different locations, or a JSON object containing the details about student marks in the exam, in which different key value pairs represent information about the students. In contrast to structured datasets, the other form of datasets is the unstructured dataset, which lacks any particular structure and do not have any fixed dimensions. This essentially means that unstructured data can take any form. Different types of unstructured data are audios, videos, images, and text. For example, consider a dataset containing images of dogs and cats, or a dataset containing the video recordings of a road highway. These datasets are the examples of unstructured data because when these images and videos are processed by machines, they are converted into long texts of bits and bytes in which humans cannot identify the right information or context. This also means that information present in the unstructured dataset cannot be represented in a well-defined tabular format. Let's talk about text data, which is one form of the unstructured data. The most prominent examples of text data available on internet are social media data, which contains tweets and posts, conversation data, which contains messages, emails and chats, or articles data, which comprises of news and blogs. So a text data is essentially any written form of a natural language such as English, Russian or Japanese. It consists of characters or words arranged together in a meaningful and a formal manner, which means that text data is driven by the grammar rules and defined structures. Now that we have discussed text data, let's talk about natural language processing. Natural language processing or NLP is the branch of data science which deals with deriving useful information from the text data. It contains several different techniques and processes which are used to analyze, understand, and utilize the text data for solving business needs. Often we come across a term called applied NLP, which means the use of NLP for designing and developing applications or systems in which there exists an interaction between machines and natural languages. Let's look at some of the examples and use cases of NLP. Take the first example of a smartphone brand who wants to find the most relevant consumer and audience preferences about their smartphones, which will help them to improve the sales of their new smartphone models. The company can make use of NLP by monitoring social media posts and tweets. From this data, they can understand the most talked about issues or problems related to smartphones, and they can find the corresponding audience sentiments associated with them. The company can then work upon the most important issues and causes of negative sentiments. Let's take the another example of a telecom company who wants to automatically categorize the customer queries to respective departments. This way, the company can reduce the time taken to resolve a customer query. The company found out that most of the time goes into identification of department which is most relevant to a given customer query. The company can create a NLP solution by analyzing the top keywords and phrases of the query. They can map those keywords and phrases to the descriptions of the respective departments. And finally, they can come up with a model or business rules for automatic categorization and assignment of queries to the respective department. In other example, a hospital wants to identify the patients which are at a risk of cancer. The hospital can analyze the history of patients, which includes diseases and drugs prescribed to them in the past. The data used in this process will be doctor notes, patient prescriptions, and other past medical records. The hospital can identify key entities from the patient history, such as the names of the drugs prescribed to them in the past or the symptoms that patient has shown in the past. This information can be modeled together using business rules to classify the risk level of the patients. While dealing with unstructured data, regular expressions can be very helpful to find information and patterns embedded in the text. In this module, I will talk about what are regular expressions, why we use them and their importance, types of regular expressions, and finally, some examples. So let's talk about what are regular expressions. Regular expressions or regex are the combination of special characters which are also called patterns. One key aspect about these patterns is that they represent a textual meaning. For example, /t is a regular expression pattern which indicates numbers present in the text. Sometimes they are also called wildcard expressions which can be used for matching, searching, and parsing the patterns from the strings. Using regular expressions, we can write rule-based information mining systems. Let's discuss why we need regular expressions. One of the main use of regular expressions is to perform segmentation of words from sentences or segmentation of sentences from paragraphs. This process is also called tokenization, which we will learn about in the next module. Regular expressions are used in text cleaning purposes to remove the unnecessary noise present in the text data. And they are also used to extract or mine relevant pieces of information from large unstructured text data. Let's discuss types of regular expressions. Here are some commonly used regular expression types. Regular expressions can be sequence of letters such as A, B, C, which can be used to find the character patterns, or sequence of digits such as 1, 2, 3, which can be used to find the digit patterns, or we can use /t to find all the digits, /w for all the alphanumeric characters, /s for space. And then there are some symbols such as star is used to match 0 or more occurrences, plus is used to match one or more occurrence, square brackets are used to match only those elements which are present in them. Let's talk about common regular expression functions available in the RE library of Python. First function is match. Match is used to find the first occurrence of a given pattern in the string. Similar to match is the search function, which is used to find the pattern anywhere in the string. Another function is find all, which is used to find all the occurrences of a pattern in the string. Sub is used to search and replace a pattern in the string. Split is used to split a given text by a given regular expression. Let me walk you through how these functions can be implemented in Python. To use these functions in Python code, we need to first import the RE library using the import statement. Consider an example in which we have a string. Tiger is the national animal of India and the pattern tiger. The task is to find this pattern in the string. We can use re.match function and check if it is present in the text or not. It will check if tiger is present in the starting of the string. In other sentence, national animal of India is tiger. If we use re.match, we won't get any result. In this case, we can use re.search. To find all the occurrences of pattern in a string, we can use find all. If string is national animal is tiger and national sport is hockey, and if pattern is national, re.find all the occurrences of the pattern in the string. Let's take another example. Let's find all the dates present in the text. For this task, we need to define a regular expression which we will be using to match date-like strings in the text. We can define the pattern /t curly braces 2 hyphen and again /t curly braces 2 hyphen and /t curly braces 4. /t corresponds to digits. 2 inside the curly braces represents that we need to find only 2 digits together. We can use find all to find all the patterns present in this text, which will give us the 3 date-like strings present in this text. The other function is re.split, which can be used to split a given text by different delimiters. For example, in this string, different punctuations are present and we want to split them by different delimiters. We can use re.split and pass the pattern of different delimiters to split the text. And another function is re.sub, which can be used to search and replace any pattern from a given string. For example, if string is cricket is a popular sport of India and the pattern is India and we need to replace the pattern by the given replacement word such as the world. So in this case we can use re.sub pattern comma replacement comma string, and in this case our pattern will be replaced by the replacement word to give cricket is the popular sport of the world. So that's all about regular expressions. We will implement regular expressions in Python. To use regular expressions in Python, we need to import re package, which we can do by the following statement. Import re. Consider a string. Tiger is the national animal of India and a pattern, say tiger. If we want to check if this pattern is present in this string, we can make use of re.match function. Inside re.match, we will pass pattern as well as our string. This function will return a match object, which we can save in a variable. Now if we print this variable, we will get an object. This is because our pattern tiger is present in this string. What if I had a different pattern, say lion? Let me name this as pattern 2. And if I was trying to find pattern 2 inside this string, and if I run this cell, I'll get none because this pattern is not present in this string. One of the property of re.match is that it only searches for pattern in the starting of the string. What if we want to search any pattern which is present inside the string? For example, if our string is same, tiger is the national animal of India, and our pattern is different, in this case say we have national. To find if national is present in the string or not, re.match function will not perform. Instead, we need to apply re.search function. re.search function works in a similar manner as re.match function. Only difference is that instead of finding in the starting of the string, re.search function searches for the pattern anywhere in the string. For example, if I pass re.search pattern comma string and I collect this in a match object, and if I print match object, I will get a match object saying one match has been found. If I have to print what exactly we have got, then we can use dot group inside 0. This will give us national, that this pattern is found in this string. What if we have more than one occurrences of a pattern? Consider a sentence. Tiger is the national animal of India and national sports is hockey. In this case, if we have to find all occurrences of a pattern in the string, we can make use of function re.findAll. In a similar manner, we will pass pattern and string in this function, which will return us a match object. In this case, a match object will be a list because there are two elements or two patterns present in the string. If we have to find where these patterns are present, in that case, instead of find all, we can use find iter function. Find iter function returns the indexes of the patterns present in the string. In this case, our match object is an iterator. So we need to iterate in this iterator. We can do this using a for loop. For example, for m in mo, if I print m.start, as in where this pattern starts, it will give us the indexes where these patterns are located inside this text. Let's look at some more examples of regular expressions. Consider a string where we have some date-like strings present in this text. For example, Ron was born on 12/09/1992 and he was admitted to school on 15/12/1999. Let's say we want to find all the date-like strings present in this string. In this case, we can define our pattern using wildcard expressions or wildcard special characters. From the video, we understood that /d is used to match all the numbers present in this text. So to find this particular pattern where we have two numbers together, then a hyphen, then another two numbers together, then another hyphen, then another four numbers together, we can define our pattern as /d, two numbers together, then a hyphen, /d, again two numbers together, and a hyphen, and in the end, /d, four numbers together. Now we can make use of re.findAll function and we will pass pattern comma string, which will give us match object. Now if we print match object, we will get all the dates present in the string. If we need to replace any particular pattern in a string, we can use re.sub function. For example, I need to replace all the date-like strings present in the string with a keyword such as Monday. So in this case, I will pass my pattern and I will replace it with Monday, and I will also pass my string name. When I print this new string in which this regular expression pattern is replaced with Monday, I'll get a string like this. Instead of saying Ron was born on this particular date and he was admitted to this particular date, now we have replaced the date-like strings with Monday. And the resultant string is Ron was born on Monday and he was admitted to school on Monday. So this was about regular expressions. I will talk about different techniques related to natural language processing. Let me talk about what we are going to cover in this module. First, we will learn about corpus, tokens and n-grams. Then we will discuss about tokenization. After that, we will talk about normalization and its two types, stemming and lemmatization. We will then discuss few properties related to text and words, that is part of speech tags and dependency grammar. First, let's discuss the meaning of the terms corpus, tokens and n-grams. A corpus is defined as a collection of text documents. For example, a dataset containing news is a corpus, or the tweets containing Twitter data is a corpus. So corpus consists of documents, documents comprises of paragraphs, paragraphs comprises of sentences, and sentences comprises of further smaller units which are called tokens. Tokens can be words, phrases, or n-grams. And n-grams are defined as the group of n words together. For example, consider the following sentence. I love my phone. In this sentence, unigrams are I love my phone. Bigrams are love my phone. And trigrams are I love love my phone. So unigrams are representing one words, bigrams are representing two words together, and trigrams are representing three words together. N-grams are very useful in text classification tasks, which we will discuss in the later videos. Let's discuss about tokenization. Tokenization is a process of splitting a text object into smaller units which are also called tokens. Example of tokens can be words, numbers, n-grams, or even symbols. Most commonly used tokenization process is the white space tokenization. In this process, the entire text is splitted into words by splitting them from white spaces. For example, in a sentence, I went to New York to play football will be splitted into following tokens. I went to New York to play football. Notice that New York is not split further because tokenization process was based on white space only. Other type of tokenization process is regular expression tokenization, in which a regular expression pattern is used to get the tokens. For example, consider the following string containing multiple delimiters. We can split the text by passing a splitting pattern. Tokenization can be performed at the sentence level or at the word level or even at the character level. Next technique is normalization. In the field of linguistics and NLP, a morpheme is defined as the base form of a word. A token is generally made up of two components, morphemes, which are the base form of a word, and inflectional forms, which are essentially the suffixes and prefixes added to morphemes. For example, consider a word, anti-nationalist, which is made up of anti and ist as the inflectional forms and national as the morpheme. Normalization is the process of converting a token into its base form. In the normalization process, the inflectional from a word are removed so that the base form can be obtained. So the normalized form of anti-nationalist is national. Normalization is useful in reducing the number of unique tokens present in the text, removing the variations of a word in the text, and removing redundant information. Two popular methods which are used for normalization are stemming and lemmatization. Let's discuss about them in detail. First of them is stemming. It is an elementary rule-based process for removing inflectional forms from a token, and the outputs are stem of the word. For example, laughing, laughed, laughs, laugh will all become laugh because their inflectional form will be removed. Stemming is not a good normalization process because sometimes stemming can produce the words which are not present in the dictionary. For example, consider a sentence. His teams are not winning. After stemming, the tokens we will get are hi team are not win. And notice that the keyword win is not a regular word and hi changes the context of entire sentence. Lemmatization, on the other hand, is a systematic step-by-step process for removing inflectional forms of a word. It makes use of vocabulary, word structure, part of speech tags, and grammar relations. The output of lemmatization is the root word called lemma. For example, am, are, is will be converted to be, running, ran, run, rans will be converted to run. Also, since it is a systematic process, while performing lemmatization, one can specify the part of speech tag for the desired term, and lemmatization will only be performed if the given word has the proper part of speech tag. For example, if we try to lemmatize the word running as a verb, it will be converted to run, but if we try to lemmatize the same word running as a noun, it won't be converted. Let us now look at some of the syntax and structure related properties of text objects. We will be talking about part of speech tags and dependency grammars. Part of speech tags are the properties of word which defines their main context, their function and usage in a sentence. Some of the commonly used part of speech tags are nouns, which defines any object or entities, verbs, which define some action, and adjectives or adverbs, which act as the modifiers, quantifiers, or intensifiers in any sentence. In a sentence, every word will be associated with a proper part of speech tag. For example, David has purchased a new laptop from Apple Store. In this sentence, every word is associated with a part of speech tag which defines their functions. In this case, David has NNP tag, which means it is a proper noun. Has and purchased belongs to verb, indicating that they are the actions, and laptop and Apple Store are the nouns. New is the adjective whose role is to modify the context of laptop. Part of speech tags are defined by the relations of word with the other words in the sentence. Machine learning models or rule-based models are applied to obtain the part of speech tags of a word. The most commonly used part of speech tag notations are provided by the Penn Tree Bank corpus, in which a total of 48 pause tags are defined according to their usage. Part of speech tags have large number of applications and they are used in variety of tasks such as text cleaning, feature engineering tasks, and word sense disambiguation. For example, consider a sentence. Please book my flight for New York. And consider an alternate sentence. I like to read a book on New York. In both the sentences, the keyword book is used, but in sentence 1, it is used as a verb, while in sentence 2, it is used as a noun. Now let's discuss about grammars. First type of grammar is the constituency grammar. Any word, group of word or phrases can be termed as constituents, and the goal of constituency grammar is to organize any sentence into its constituents using their properties. These properties are generally driven by their part of speech tags, noun or verb phrase identification. For example, a constituency grammar can be defined that any sentence can be organized into three constituents: a subject, a context, and an object. These constituents can take different values and accordingly can generate different sentences. For example, the dogs are barking in the park. They are eating happily. Or the cats are running since morning. Another view to look at constituency grammar is to define their grammar in terms of their part of speech tags. Say a grammar structure containing a determiner, noun, adjective, verb, preposition, determiner, noun, which corresponds to the same sentence. The dogs are barking in the park. A different type of grammar is the dependency grammar, which states that words of a sentence are dependent upon other words of the sentence. For example, in the last sentence, barking dog was mentioned and dog was modified by barking, as the dependency adjective modifier exists between the two. Dependency grammar organizes the words of a sentence according to their dependencies. One of the words in a sentence acts as a root, and all the other words are directly or indirectly linked to the root using their dependencies. These dependencies represent relationships among the words in a sentence, and dependency grammars are used to infer the structure and semantic dependencies between the words. Let's consider an example. Consider a sentence. Analytics Vidya is the largest community of data scientists and provides best resources for understanding data and analytics. The dependency tree of this sentence looks something like this. In this tree, the root word is community, having NN as the part of speech tag, and every other word of this tree is connected to root directly or indirectly with a dependency relation such as direct object, direct subject, modifiers, etc. These relationships define their roles and functions of each word in the sentence and how multiple words are connected together. Every dependency can be represented in the form of a triplet which contains a governor, a relation, and a dependent, which means that a dependent is connected to the governor by a relation, or in other words, they are subject, verb, or object. For example, in the same sentence, Analytics Vidya is the largest community of data scientists. Analytics Vidya is the subject and plays the role of a governor or the verb. Largest community of data scientists is the dependent or the object. Dependency grammars can be used in different use cases. For example, they are used to solve named entity recognition problems. They can be used to understand relational and structural aspects of question answering systems. They are also used in co-reference resolutions, in which the task is to map the pronouns to the respective noun phrases. They can also be used for text summarization problems, and they are also used as features for text classification problems. We will be using NLTK package to implement the NLP tasks studied in the previous video in Python. So the first topic is tokenization. We studied that tokenization is a process of getting sentences out of a list of sentences or a document, or getting words out of sentences. So consider an input text that we will be using. Hi John, how are you doing? A delimiter. I will be traveling to your city. Let's catch up. Notice that this is a paragraph which contains multiple sentences. Now if we can use NLTK package and import its tokenize function, using send tokenize, we will be able to split this text into multiple sentences. For example, if we pass send text inside the send tokenize, we will get a list of sentences which contains hi John, how are you doing? I will be traveling to your city, let's catch up. So instead of send tokenize, let's say if we want to use word tokenize, first of all we can import it, and in order to obtain the words, we will pass the text into word tokenize function. This will give us the list of all the words which are present in this text. So this was tokenization. Next, let's discuss stemming. Stemming is one process of normalization family in which sentences or the words are reduced to their base forms by getting rid of their inflectional forms. So first of all, we can import NLTK stemmer, which is provided in nltk.stem class. We will specifically use porter stemmer, which is implemented in Python and it is included by default in NLTK package. We can make an object of this class, and let's say we now print some sentences or words. Let's say our word is playing. If I run this, it will be converted to play because its inflectional form is removed. If instead of playing I had, let's say, plays, in this case inflectional form is further removed, and if we have, let's say, played, it will also be changed to its root form. However, stemming is not a very good normalization process because sometimes it can produce the words which are not present in dictionary. For example, consider this word, increases. If we try to run it, it produces a word increase, which is not a dictionary word. So stemming is not a good choice for normalization. Instead, we can use lemmatization, which is also provided in NLTK package. We can import WordNet lemmatizer using this command. We can then create a class of same WordNet lemmatizer. WordNet lemmatizer is nothing but an implementation of lemmatization. And now if we, let's say, run the same thing for increases, instead of stemming we now want to lemmatize this. In this case we will get increase as the output. Consider some other words such as running. This will be converted to running because we haven't defined the part of speech tag. As discussed in the last video, I talked about that we need to pass a part of speech tag. We need to make use of part of speech tag. So if I pass verb as the part of speech tag, running will be converted to run. Next, let's implement part of speech tag. So from NLTK we can import pause tag and consider the same sentence that we had previously. And first of all, if we word tokenize it, we will get a list of tokens, and now we can pass these tokens into pause tag function, which will annotate all of the tokens with their corresponding part of speech tags. NLTK has also integration with WordNet, which is a very comprehensive vocabulary of all possible words, and some functions such as getting synonyms, antonyms can be applied. So let's see how we can do it. From nltk.corpus I will first import WordNet, and let's say I have to get the synonyms of a particular word, so I'll just write wordnet.synsets and my word, let's say my word is good. In this case I'll get list of all synonyms of a word. We can see good having the noun part of speech tag, commodity, full, estimable, beneficials, etc. What if I say get the synonym of computer? In this case, I'll get computer and calculator. NLTK can also be used to implement n-grams. For example, if we write from NLTK import n-grams and my sentence is, let's say, I love to play football, and I need to implement n-grams, or in other words, I need to obtain all bigram combinations from this sentence. I will make use of this n-gram function. I'll pass my sentence and I'll pass my n. Instead of sentence, I'll need to pass word tokenize, or basically list of words, and an n. In this case, let's say I want to obtain all the bigrams, so I'll pass n equals to 2. This is returned a generator, so we can iterate in it in order to obtain all our n-grams. So these are all the bigrams that have been obtained. Thank you.